Hello. So I'm gonna solve this thing here using this method and the shell method. All right, and I've already done this before. Okay, this exercise in here, I've already completed it before, and I use the this method. So using the this method, you know that, well, let's see here. All right, so let me increase the contrast for it to be easier for you guys. You see, we're going to make these horizontal bars that are going to go around, see, the y-axis. So in order to do that, we make these horizontal bars. Okay, this one here is always going to be 1 up to here, okay, up to the dotted line. This is always going to be 1, so I'm not even going to use integral to do this. I'm just going to say, look, it's pi times the radius. The radius is 1. The radius is 1 because of this distance here. Okay, this is going to go around. So pi times 1 is pi, times 1 in the height right here is just going to be pi. So this thing is going to be pi plus. And now we got to do pi, the integral of what? Of the great R squared of this R squared of x minus little r squared of x. Why? Because we're talking about this curve, right? So, for example, the great R is just going to be 1, which is this border right here. I'm going to make this go around, and then I have to deduce, or I have to subtract the radius of this disk in here. Right, guys? I mean, this right here, for example, this point is going to go around making a big disk, okay? And now you have this point right here, the same height, also going around making a big disk, except that this this disk in here is empty, okay? That's the hole. So let's do that. Hold on. So the big is going to be r squared of x, which is 1, right? Minus this little r here squared of x. Oh, as a matter of fact, it's y, right? Because we're integrating, I'm integrating with respect to y. So it's r squared of y minus little r squared of y. And the little r squared of y equals square root of y minus 1. So minus y plus 1 dy. So let's do that. Oh yeah, and I'm integrating from 1 all the way to 2. Y equals 1 to y equals 2. So there's just going to be 2 here. I'm going to erase this thing, bring this over, and here's got a 2. Okay, so it'll be pi plus pi times 2y minus y squared divided by 2. Okay, from 1 to 2. So it'll be pi plus pi times, it'll be 4 minus 4 divided by 2, 2 minus 2. Now we gotta put in 1 in here, it'll be 2, but it's because it's minus minus 2. And you have this 1, so it's half minus half, but it's plus half. Okay. It's plus half because of the minus, right? So this is going to be a minus, and this is going to be a plus when you're plugging in the 1 into the y. It's going to be, well, this thing here is just going to be cut, right? And the whole thing is pi plus half pi, which is 3 pi divided by 2. Okay, so you know what I'm going to do? I'm going to keep this final answer, okay? So 3 pi divided by 2. That'll be the final volume. Well, now I'm going to integrate with respect to x, right? Because I'm going to use the shell. So I'm going to make this thing here, which has a radius of 0, go around. So it's just going to be 0, plus this one going around, plus this one going around, plus, right? There you go, going around, plus this, going around this way here, okay? So it's gonna be 2 pi times the integral of what? Well, for example, when I'm gonna use the, because this figure here is using, it's showing off, this illustration is showing off the disk method, but I'm not going to use the disk method, so these horizontal bars here are no longer valid, okay? I'm going to make a very thin bar like this, okay? And we're going to think about that. So we have a distance, you see, you have this distance here, and you have this distance here. Now they usually call this f of y, or not, yeah, and they usually call this p of y, okay? Is that it? No, it's f of x, yeah. Because f of x equals y, and this distance is the distance in y, okay? And this thing here is just gonna be p of y, p of y. Oh, that's strange. I'm gonna use the thing, it's gonna be p of y, which is just a y, okay? And you have this thing here. Okay, anyway, guys, using the shell method, the bars are gonna go along the axis of revolution, and since we have y as the axis of revolution, we're gonna use dx. Let me just put the dx in here. Okay, now what is this p of y? Because it's going to be 2 pi r. This p of y is the r, okay? It's just x. It's exactly where the bar is standing. So you put an x in there, okay? And then you have to find this value of y for the value of x. Well, you see here you have r equals square root, right? Y minus 1. And we know that it's positive, guys, because you see the whole thing here. This whole thing here is on top of the x-axis, okay? So you don't have anything down here. There's no negative y. Yeah, this is going to be the value of x, actually, because x is a function of y, okay? So you have this equals x, which equals a function of y, okay? But here's the thing. If I'm going to integrate this with respect to y, okay, with respect to x, then I have to use y as a function of x, not x as a function of y. So you have this r is just this distance. This is going to be x, okay? So pay attention to this thing. I'm going to switch. I'm going to put the x on the, well, okay. I'm just going to square it. So it's going to be y minus 1 equals x squared. Y equals x squared plus 1. All right. So this is going to be the f of x. So you have an f of x in here, and you got a p of y in here. Okay. Or you could call it an f of y, but f of y is weird because f of y is the x. Anyway, you have to multiply these things because why is it going to be? Why do you have to multiply it? You got to multiply this x by this value. Why? Because it's 2 pi r. What's going to be the r? R is just going to be this distance here, okay, times this distance here. That's why you have to multiply them. Okay, so you have an x in there, times this stuff is just going to be x cubed plus x. And there you go. The thing's already set up. Okay. So it'll be, I'm going to separate this. This equals 2 pi, and the integral with respect to x, right? X to the 4th divided by 4 plus x squared divided by 2. Oh yeah, and now that I'm integrating with respect to x, it'll be from 0 to 1. just to make sure that you know what I'm talking about, it'll be from here to here. So from 0 to 1, from 0 to 1. Don't have to worry about the 0 because when you plug 0 into these x's here, you're going to zero out the whole equation. So this equals 2 pi times 1/4 plus 1/2. Okay, now let's put a 4 here and let's put a 2 here. So this is going to be equal to 3 divided by 4, right? So 2 pi times 3 divided by 4. You cancel this and you put a 2 in here, and look at that, 3 pi divided by 2. Look, 3 pi divided by 2 here, 3 pi divided by 2 here. Okay, so it doesn't matter how you get the volume of the solid revolution, whether you're going to use the disk method or the shell method. The result's going to be the same because the volume is just one. It's one object that you have. But whether you choose the disk or the shell method is just going to depend on the axis of revolution and the shape of the curve. Okay, the horizontal bars or vertical bars, which ones are going to be easier to set up. So yeah. Let me see if I want to do another one in here. Oh, this is strange. Okay, can do another one here. Another exercise. Now you see, the axis of revolution is the y one. Now, if you're going to use the disk method, you have to do this. Well, actually, I think this is already the stuff that we just did. Yeah, this is the stuff that we just did. I'm sorry. This one's gonna be easy. You want to find out the volume of revolution that's gonna happen when you get this curve and you rotate it about the x. So we can just use the disk method instead of the shell method. But why don't I want to use the shell method? Because if you're using the disk method, it's pretty straightforward, right? You have, I'm not going to make perfectly straight lines in here because I'm in a hurry. So you're going to do this disk plus this one plus this one plus this one, where the radius is this, okay? So it's pretty straightforward. If you're going to use the shell method, the bars are, because the axis of revolution is the x-axis, so it's a horizontal axis, the bars are going to be horizontal. I'm going to have to do 2 pi times, look at this, this is one of the bars. So it'll be 2 pi times this distance, okay, which is just y. But then you have to do times this length in here. And what is this length going to be? Well, it's going to be this x minus this x. For this y, I'm going to have to find 2 x's. For this y here, I'm going to have to find 2 x's, this one and that one. So no, you just want to use the disk method. Let's do it. Let's do that. It'll be pi. This is going to be 1 minus x squared divided by 8 plus x to the 4th divided by 256 dx, right? Let's try it. Equals pi times x minus x cubed divided by 24 plus x to the 5th divided by 1280. Okay, going from -4 to 4. Well, let's see. Pi times. Yeah. Okay, it'll be 4 minus 64 divided by 24. Right now, I'm not gonna simplify it. Plus 1024 divided by 1280. Okay, minus. Now, oh yeah, maybe I made a mistake in that. I'm gonna put a -4 here with a minus plus 4. This is gonna be my minus. It's gonna be 64 over 24. Put a minus here. It's gonna be minus, okay. It's gonna be 1024 divided by 1280. Okay. So, yeah, the second one here, let me think. It's gonna be negative, positive with a negative, negative. Yeah, that's why I made a mistake. Okay, anyway, let's see. Nope. Let's try to simplify this thing as much as I can. I'll have to find the minimum common denominator here. All right. Well, let me think. Instead of doing that because I'm in a hurry, I'm just going to say this is going to be 8, right? It's minus 64 with a minus 64 minus 128 divided by 24 plus 2048 divided by 1280. Okay. And now let me do this thing in here. 128 divided by, well, let me see. Because I want to try to do this manually. I know it's a pain. I want to try to do it manually. So the same is going to be 64 over 12, 32 over 6. Yeah, I think that's it. So this is actually 32 over 6. Oh yeah, I can do 16 over 3. Okay. Now this one, it'll be 1024. And here we have 640, right? Yeah. This is going to be 512, 320, 256, 160, 128, 80. Dividing everything by 4, we got 32 over 20, and then you have a 16 over 10, right? 8 over 5, yeah. So this is going to be 8 over 5. Okay. So checking the minimum common denominator now. 15. 80 plus 40, 120. Okay. Minus 550 times 80, right? Plus 24. And now we have a pi here. It'll be 40. 40 plus 64 over 15. Yeah, this is the right answer. There you go. That'll be the volume of this shape in here going around the x-axis. Okay, and I solved it using the disk method, not the shell method. Okay.